Hello, my name is Brian Martin, and I'm currently a network engineer with East Carolina University. Today, I would like to talk to you about VPN types and their protocols. First off, we'll start out with some basic stuff about like what is a VPN and some types, just some stuff that most of you are probably aware of, but we'll just kind of briefly cover over. So, what is a VPN? A VPN is a virtual private network that is an encrypted tunnel created over the internet to connect remote sites or employees to a network. And there are essentially two types of VPN types. There's a site-to-site VPN, and there's also a remote access VPN. I'll kind of delve in a little bit, more of the two, but as you can see, the site-to-site is basically used to connect a encrypted tunnel or a VPN from one network to another network. A remote access is basically used to create a VPN tunnel or an encrypted tunnel from a network to a remote user. Next, we'll go delve into the site-to-site VPN, and this type of VPN allows offices or campuses in different locations to connect securely with each other over a public network, as you can see in the demonstration. And before they had VPN, available. Remote locations used to use lease lines or integrated services digital network or ISDN as the way to connect remote sites together. But since technology advances have come about and the rising cost of these lease lines have been basically been rendered non-viable for organizations to use them. And also with a site-to-site, it's not just one location connection. It could be multiple remote sites locations with a VPN tunnel created for each one, going back to the main network hub or the main organization. Some advantages to a site-to-site VPN. Site-to-site VPN setups can also branch multiple remote sites back to one location, as I just mentioned. And also, site-to-site tends to be much cheaper than having lease lines for each remote site. If you were to have a T1 line or any other type of lease line, they would be pretty expensive as compared to having a VPN tunnel set up for each location. And the last advantage is it's easier for users at the remote site. And instead of having, a user having to load up software or connect, through the VPN via software connection, that tunnel is already there once they get online. And so they can work freely without having to worry about whether they logged on or logged off of the VPN while they were working. Some disadvantages to site-to-site VPNs. With site-to-site VPNs, you lose mobility on where you can send encrypted traffic due to the static VPN tunnel at the static site. Those people would have to work at that location to get the benefit of having that encrypted tunnel to work, in the remote location. And another disadvantage is you need somebody with more technical knowledge that can be able to set up a site-to-site VPN, because most of the time it's generally done with a router or firewall or a VPN concentrator. So you'll need somebody with the technical expertise to be able to set up this site-to-site VPN. And the last disadvantage is they're more expensive with needing extra hardware, such as your routers, firewalls, VPN concentrators, like I just mentioned, to create the site-to-site encrypted tunnel. But yet they're still cheaper than having leased lines. But you still have to have these type of equipment, this type of hardware to create these VPN tunnels. Next, we go to remote access VPN. This type of VPN allows a remote client or user to connect back to an organization's VPN or network without using any special leased line or hardware. So basically, this is the situation where you have remote users, that work from home. They have a VPN client like a Cisco Anywhere client or something to that nature, and they log in directly to their network using that VPN client, which is gives them secure tunnel, and it also gives them the room to be able to log in at public Wi-Fi networks or any other, if they're traveling or something like that they could log into. And this is where, like, it shows in the actual the picture. It's a encrypted tunnel, that's created, formed by a software client that connects back to the server's organization. All right, some advantages of remote access VPN. And the first one, it allows companies and organizations to offer an affordable way for employees to work off-site while keeping the data transfer protected. That's pretty simple, as it gets. It's more and more you'll see corporations going to having a workforce that is remote and people that work from homes. And I currently have a friend right now that's lives in North Carolina, but his job is in Florida, and he connects via VPN through work and stuff. So this is kind of becoming a common thing with today's the business world. The second advantage is it gives users and clients peace of mind knowing that they can work securely while logged into a public network and traveling abroad. And that kind of touches on something about what I said earlier, just a while ago about, people being able to travel and being able to work efficiently and, peacefully, knowing that their stuff, their encryption, their data traffic is being secured for the most part. Doesn't make it foolproof, but it's a lot better than the alternative of not having a VPN. And the last advantage of remote access VPN is companies can save space and money by promoting remote access for employees to work at home. And it goes back to what I was saying. This is kind of the trend of how corporations are doing now. They're having a more remote force than a come into the brick and mortar building type, force where they need the space, the electricity, and all the other stuff that to accompany all these employees. So that way they can work from home, and that way companies can reduce costs and stuff. Okay, let's move on to remote access VPN disadvantages. And there's currently two of them, and that's in the remote access. It basically in the organization's ability to control the security on a user's computer is limited. Most of the time, a computer that a user is using at home for work purposes is generally a private one. So if you have a situation with a remote access VPN, a organization is not going to be able to push policies and stuff to that device and stuff, like it would be if it were on like a site-to-site VPN or something to that nature. That's the one drawback about the remote access is you're only as good as the security of that person's that user's computer. So if it's corrupt, or if it's compromised, then that VPN connection will be compromised too as well. So you have to make sure you have good user training, and so they will be aware of what not to click, and to safeguard themselves. The second disadvantage for a remote access VPN is bandwidth can be an issue to VPN speed if there are a lot of remote access users. So you've got 100 remote access users all hitting one VPN concentrator. Well, it's going to kind of slow things down, and so this is one of the drawbacks of having a remote access VPN. And next we'll go to VPN protocols, and we'll cover PPTP, L2TP with IPsec, SSTP, and IKE version 2, and OpenVPN. The first of the VPN protocols, and this is the first thing that's ever been invented, was the point-to-point tunneling protocol, PPTP, which was developed by Microsoft back in 1995, and it was basically used to work with dial-up connections. Your old modems that you used to have to dial-up internet and stuff. This is what used to create the tunnel or the connection back to your landline, with your landlines and stuff. And even today, it's still popular because it's integrated into Windows, Linux, Mac OS, and older mobile devices. So it's not something that's gone away, even though there have been things to replace it. The next VPN protocol is L2TP, which is layer 2 tunneling protocol, and it's the successor protocol to PPTP. And L2F. L2F was a protocol that was designed by Cisco. And L2TP, sorry, I get tongue-tied, does not provide any encryption itself. It's basically, the tunnel protocol that actually creates the tunnel. And what it does, it bundles itself with IPsec to provide a 256-bit encryption to keep the data actually, safe. The next VPN protocol is SSTP, and this is secure socket tunneling protocol. And this VPN protocol was also developed by Microsoft, and it has been in every Microsoft operating system since Vista Service Pack 1. And it uses a 2048-bit SSL TLS certificates for authentication, and uses a 256-bit SSL keys for encryption. And it supports Windows, Linux, BSD systems, Android, Mac OS, and iOS support via third-party clients. And you can see, in the frame below, a picture of the actual tunneling negotiation, SSL negotiation being, going back and forth. And you can see where the actual packet frame is actually encrypted by the SSL session. On to the next protocol is IKE version 2. This is Internet Key Exchange version 2, and this is the proprietary protocol developed by Microsoft and Cisco. It's a joint venture. And this is also a tunneling protocol that provides a secure key exchange session without encryption. And it's usually, this is also usually paired with IPsec for encryption and authentication. And as you can see, the initiation and exchange on the right side, of this key exchange occurring between a laptop and a server. And this protocol, VPN protocol, is really adept for devices that are mobile VPN, that require like mobile VPN solutions. And the reason being is because the protocol is adept to reconnecting during inconsistent internet connections. And so if you have something mobile that kind of goes out or that's spotty, this would make a good VPN protocol to use, since it's able to adapt to reconnecting easily. And the last VPN protocol is OpenVPN. And OpenVPN is open source protocol that is highly configurable and able to support different encryption types in various ports. And it comes in two flavors: OpenVPN TCP and OpenVPN UDP. Now, OpenVPN TCP is probably one of the most reliable VPN connection types because it uses that TCP error correction to prevent packet or information loss in transmission. So it makes that VPN connection very reliable. And the next one is OpenVPN UDP. Now, this is the faster of the two of the protocols because it doesn't have the error corrections that the TCP does, and to prevent data or packet loss. So it's basically you're giving up speed for reliability, or you're giving up reliability for speed rather. And this protocol, it does have a high overhead, which often lowers speeds, which is this is one of the main complaints of OpenVPN protocol, is that the lower speeds. And that concludes my my presentation for today. Thank you for listening, and have a good day.